Thank you very much for the organizers, and I would like to thank particularly Professor Murawska and Odis for being so welcoming to all the group that is here. And I'll talk about, I'll talk about the ME-CFS, the experience of we had by creating a disease-specific biobank at the London School of Hygiene and Tropical Medicine in collaboration with other institutions. And my presentation will be mainly on how we managed to create this biobank as a facility to enhance research in a very specific area. So why to discuss partnership and participatory research is one of the main topics that we are discussing today, presenting today. How we have done this, how we improve participation in the biobank and participatory research, using participatory research. And I will present to you the specific design for a disease-specific biobank, which is the UKME Biobank, the first one in the UK for this facility, and probably the first one in the Europe as well. There is one disease-specific biobank in the US, and now we have other around the European countries. So, why to discuss partnership? I'd like to ask the few colleagues who are staying here with us and to ask you that do particularly basic research to zoom out from your labs and to look into some keywords that are more related to clinical work. So one of them is respect and transparency of research, particularly related to our research subjects. Trust in the communities that we have to build this trustful relationships with our research subjects. This is a topic that is very dear to me, is to establish dialogue, a lay scientific dialogue, because the communities have usually they have some very specific knowledge that can improve our understanding of the world we are studying. And also all of these keywords drives us to do what I consider ethical research. So, coming from the micro world that you probably, the majority of you are more familiar with, I would like just to show you a very specific example of the Ebola situation that I'm sure all of you are aware of. And the London School has been involved in the response, the international response to this outbreak in Africa countries. And I would like to, just with these images, to show you why we have to develop this ethical research with the involvement of the communities. Because if we, in addition to the whole situation, not only political situation, but this, as a result of this political situation on the countries that were affected by the Ebola outbreak, there was, and in despite of their completely shattered health systems, we have a massive response, international response, not only from academia and institutions that usually goes there, official institutions. The most interesting response and more prompt response was from the NGO association called the Médecins Sans Frontières. And you can imagine, just by looking at this picture here, drawn from Lydia, that it was a kind of amazement in her gaze at looking at this completely strange figures with the whole suit and how they have buried people, bring these people to the treatment center. When they died, they buried in mass graves. And then, in spite of the whole problematic situation that the countries were dealing in relation to response, they have the situation where the communities were hiding their dearest ones when the virus was at the most transmittable for people, because they thought that their dearest ones that were infected were bring to these treatment centers. They were buried in mass graves, and their souls were lost. So they were hiding from the health services, their people. So this is why I think that at least we should engage with the population. And the outbreak started getting response only after social researchers, particularly medical anthropologists, went to the communities and started building meaningful and trustful relationships with these communities. So, if this is not sufficient, one of them is compliance with regulatory bodies. If you don't comply, you don't get grants. You don't go to prison like that, but probably you will not get grants. And this is something that is, just to give you some references, all research groups working with human bodies, human tissues, and derivatives have to comply in European countries, and also for those who had NIH grants, they know exactly what I'm talking about. They have a lot of regulations. You are obliged to comply with ethical procedures. So I think that in our research, it's very dear to me, the participation, because we can just go through the ethical compliance, and it's also fun. So to build this ME-CFS Biobank, to establish the ME-CFS Biobank, we proposed to do a feasibility study to set up a disease-specific biobank that was acceptable, cost-effective, and compliant with the ethical and legal frameworks. The feasibility study was funded by two main charities in the UK, the Action for ME and the ME Association. And we started a consultation process that we used qualitative methods with focus groups with people with ME-CFS. And then, after the results of the focus groups, we presented the results for a workshop with researchers, clinicians, experts in diverse fields, including human tissue banks, law, and ethics. The main topics that we used for the focus group discussions were the willingness of people with ME-CFS to donate blood and other tissue samples. Derek mentioned the possibility of establishing a post-mortem tissue bank, and we had a separate feasibility study for that. What will be the main barriers for the initiative, and who will be our target donors, I mean blood donors. The general response from the groups we studied was that people with ME-CFS were happy to donate blood, particularly for altruism, for taking part in what they call the new exciting step forward. This means that we are going away from what they consider the biosocial model of explanation of disease, meaning that they don't have only the psychiatry disease, but they have something that it was physical and biophysical. And this will give them some empowerment. So just to illustrate the empowerment, this was a quote from one participant saying that also you feel sort of powerless, and so much is taken away from your life. I think that it might have a good psychological impact, and if people felt they were able to do something positive. Because just it made me feel, just coming here today, that I might doing a little bit. So this participant was she was almost homebound, and she came to participate in this discussion, and just by going there, she felt that it was good, not for her. She was not hoping that we find a cure for her, but she could do for other generations. So, but still, it's interesting to find out that in a country that is praised by democratic standards like UK, people are afraid that what the government will do with my blood. So if they get a hold of the samples, what the insurance companies will do with this, or benefit agencies will do. So there is a kind of concern about what we are doing with the samples that are stored. And also, they have the same concerns as we scientists have. This means samples have to have very good quality, and we have to have appropriate data that enables good results. So, in summary, what they told us, that we have to have a good case definition, that by now ME/CFS is clinically defined. We have to have a careful data collection, and the target donors should include severely affected. By severely affected, we are talking about an estimated 25% of people who had been bed-bound or at least homebound with this condition. And as healthy controls, one concern is to include non-blood relative controls to avoid some kind of bias, genetic bias. The importance of feedback, this is interesting because in the majority of disease-specific biobanks, particularly the genetic ones, people want to know what they have. If you find some results, even if it's in experimental terms, they want to know. And people with ME don't want to know. They don't want medical reports. They just want a general report. And another thing that they thought it was important was to market the biobank. And this is what we are doing here. We are marketing our disease-specific biobank, which should be used not only by us, but by all people who are interested in doing research with us. And for marketing the biobank, we should have careful wording. We should assure anonymity and all the description of procedures. So we managed to get a feasible and cost-effective biobank with a very specific recruitment process, targeting potential donors, with a very standard operation procedures, very well designed, and to have open access for ethically approved biomedical research. So how could we manage to, with a very small funding, to fund biobank, disease-specific biobank? Firstly, we have this small funding from the now 3 main associations, including the Research ME UK, in addition to the 2 previous ones, and a private donor who want to remain anonymous and whose wife was the sufferer. We have this small grant that finished last year. We managed to recruit 140 participants with this grant and some healthy controls. And since 2013, we had a grant from the NIH, which is for our own research, it's research in virology and immunology for biomarker discovery. But we, with this grant, we could expand the collection of data and samples to increase the biobank sample. So, who are our target population? We have cases confirmed with two main diagnosis criteria used, the Canadian and the CDC 95. We are recruiting people from 18 to 60 years old, obviously informed consent, and we are including 50 severely affected cases. We have healthy control, a group of healthy controls, and the NIH peer review asked us to include a chronically fatigued group. So we include a group of multiple sclerosis patients. Also informed consent, matched by age, gender, and area of residency. So our recruitment strategy, we started recruiting participants from the primary health care centers in the UK, particularly in east of England, this region here, and in some secondary care services in London area, including the Royal Free Hospital Biobank, UCL Hospital, the Royal London Hospital for Integrated Medicine, and another hospital including the Imperial Group. So these are mainly our recruitment centers. We train research nurses to apply our research protocol. And we use support groups for the severely affected participants who are not going anymore to the official medical services, health services. They are mainly homebound, and the GPs usually say, we don't have anything to help you anymore. So in terms of ethics, just to give you an idea, we have to have national approval. This is streamlined to the research and development offices, all these approvals. We have a London School Ethics Committee approval and the Human Tissue Act license. Our biobank is being nested within a biobank who had the Human Tissue Act. So this is a UCL Royal Free London Hospital Biobank, and we process and store our samples there. This is just an outline of our recruitment procedures, which is started by the GPs or, in the case of severely affected, the support groups inviting participants. Once they gave consent, they have clinical assessment and collection of samples booked. We have some lab tests for baseline to exclude other conditions, and if they are not excluded, they comply with one of the entries in the study. We have the confirmed cases, the group of non-ME/CFS cases, a group of healthy controls, and MS cases, and all the samples are processed, stored, aliquoted, and stored at the Royal Free Biobank. So these are just charts showing the samples. We are collecting around 12 tubes of samples, and these are processed, giving us. These are our storage facility at the UCL Royal Free Biobank. Just to show you. So we have aliquots of whole blood, serum, plasma, red blood cells, PBMCs, and blood for RNA with packed genes, collected with packed genes. So now we have a bit more than 1,500 aliquots stored. And these are just the baseline tests that we have been running into the patients, and these are clinical data that are stored in our database at the London School. It's important to know that all the samples aliquots are anonymized, and we have separate storage facilities for the identifiable data and for the non-identifiable data, including clinical data. We intend to release samples for colleagues who are interested in testing new hypotheses, and the priority areas for the biobank are new hypotheses of pathophysiology in ME/CFS, improving diagnosis and basic science, potentially leading to clinical trials or therapeutic approaches. The procedures are to submit the application to the Biobank Steering Committee group, who I'm proud to say is composed by researchers, by the initially funded associations, and by patients themselves. So we have a representation of, at the moment, 3 patients and 1 carer for a severely affected participant. All the projects have to have ethical approvals. We send to peer review, and anonymized aliquots will be provided by researchers. We are intending to send these, to release samples by August, to open the biobank August, and probably releasing samples by January after all these procedures are taking place. So now our biobank is being used as a kind of example, and we are sharing our protocols with colleagues in Norway who had a CFS Biobank. They started collecting samples 1 year after we started. We have some collaborators in Germany, Spain, Italy, Sweden, and now, since a few years ago we started designing this collaboration with Riga, and now with the Baltic Fact we hope to strengthen this collaboration. So in summary, the UK ME/CFS Biobank was established successfully with partnership, not only with the associations but with patients themselves. Our model has been shared and our protocols has been shared with other European countries. We could optimize, by doing this, we could optimize the cost effectiveness of the samples. We have a cost-effective design just by being nested into the biobank, who had all the freezers and all the security procedures in place. And this gave us wider opportunities for collaboration. And also, we should say that it's very important to use disease-specific biobanks because we have good quality samples, we have a careful approach and very well phenotyped participants. And the health economists who have been looking at the usage of biobanks, they say that you can reduce the grant costs by 10% of the original cost that you had to recruit, not even considering the time you had to recruit. For example, now we have recruited almost 300 participants to the biobank, and we are having a second time point of collection samples. And we have been doing this since 2013, so you have at least 3 years that if you want to use the samples to get the samples ready for you. Thank you very much.
Well, thank you very much, Aldis. Like Eliana and Nuno, we come from the Faculty of Infectious and Tropical Diseases at the London School of Hygiene and Tropical Medicine. And Eliana and myself are part of the QME team at the Clinical Research Department at the London School. We'd like to start by thanking very much our colleagues from Riga not only for the preparation of this excellent conference, but also for the opportunity to collaborate in research and to learn from you and share our experiences with you. I also like to thank all those of you who remain here in the room at this time of the Friday afternoon. And also to all the colleagues who have been presented since Tuesday, or since Wednesday actually, and who taught me a lot about areas that I'm not directly familiar with. So I come from the clinical background. My background in clinical medicine, public health, and epidemiology. So I think I'm good at understanding the problems of my patients and the populations I work with, and I try my best to try to find solutions, come with solutions, which is not always straightforward. And what I learned a lot during this conference is about the ability of mathematicians and people working with mathematical models to actually provide mathematical solutions to problems. And of course, it's very important communication in all this. Santo Mota was talking, I think, yesterday about the fact that mathematicians without us will simply be playing video games. And if we are alone and we don't work with you, then we'll be losing or missing a very, very significant opportunity to do a better job. So in all of this, and Eliana told you just now about the importance of partnership with participants, with people with conditions. Nuno's told you a little bit more about the various musketeers that we need to be involved, or in other words, about the importance of multidisciplinarity when trying to address research questions. And I think, in particular, we need to be ready to sit down with mathematicians and ourselves from the other side and work together in formulating the right questions so that we can have the right solutions to our problems. And of course, Vladimir was pointing out in his early presentation this afternoon that what garbage in is garbage out. What you put into a system or a model is what comes out. And unless you're actually dealing with sewage mathematical modeling, which is the case of this publication here, actually what you want is sensible outputs of your model. So I presume many of you have not heard about any CFS or don't know much about until Derek came and gave his presentation about the subject followed by Eliana. And just to remind you, now we start to become experts in the field, when someone has fatigue, which lasts for over 6 months and is persistent or recurrent, and which cannot be explained by other conditions such as multiple sclerosis, for example, which is very fatiguing illness, or cancer, or even many endocrine problems such as diabetes or thyroid problems, which, if not well controlled, can cause a lot of fatigue. And this fatigue actually affects life and promotes some level of disability, so that people reduce their activity levels compared to what they were able to do before. Then we're talking about chronic fatigue syndrome. So it's quite a broad definition, and it's important to realize that there is no biomarkers for this condition, and also that for the case definition to be completely satisfied, you need some further requirements in addition to the requirements I just mentioned to you. So it's not only about having chronic fatigue for over 6 months, but also, as this example illustrates, based on the CDC 94 criteria, it requires a diagnosis of ME or chronic fatigue syndrome. It requires not only chronic fatigue, which has significant impact, but also 4 out of 8 symptoms from this list here that appears here, which includes, for example, unrefreshing sleep, cause exertion, and less for more than 24 hours, headaches, and etc. So if you do a little bit of math, and apologies for the mathematicians here, this is a very simple formula, but I hope I got it right, and the combinations that are possible when you have when you can choose 4 or more symptoms out of 8 symptoms, then we get, in this case, with 163 possible combination of symptoms, all of them would meet the criteria for chronic fatigue syndrome. So this seems problematic. Not only because there is so much variability in what we describe as chronic fatigue syndrome, and many of the symptoms also being quite non-specific, but also because this criteria I just mentioned is one of over 20 criteria that have been created to diagnose the condition. And I'm just listing here 3 different criteria which are among the most widely used. And one is the CDC 94 that I just presented, which has chronic fatigue, exclusion of known causes, and then, as I said, 4 out of 8 symptoms need to be present. And this is the Canadian definition, which is very popular nowadays, which is created in 2010. And this is the recently published Institute of Medicine definition, which just came out three months ago, or about 3 months ago. And you see that each definition, and don't forget about the other 20 that have been created, they have some things in common, but there are differences. For example, if you look at cognition, for the Canadian definition, cognitive disturbance needs to be present for a diagnosis to be made. For the CDC 94 definition, cognitive symptoms is just one of the symptoms that may or may not be present for a diagnosis. And according to IOM definition, you can either have cognitive symptoms or orthostatic intolerance. So it's not a compulsory symptom. So this is just to summarize the complexities of what we're talking about. And I think from now onwards, I hope this presentation will at least stimulate people from the mathematical modeling field about some questions, because I'm talking here not about solutions, I'm talking about formulation of problems, and then maybe we can be thinking in parallel, and I'll be asking you at the end, what solutions can your field perhaps offer us to help sort out this big puzzle, which consists of the fact that chronic fatigue is very common. 1 in every 3 patients that come to see me in general practice, they have some form of fatigue. I presume at least half of you will be fatigued now after 3 days of intensive conferences and lectures, and this is normal. This is part of a human being. Of course, some people have chronic fatigue for 6 months or more, and some people have chronic fatigue syndrome, and even a smaller number will meet one of the criteria we've been talking about. Which is, as I said, defined by a combination of symptoms, because there is no blood test or molecular test or biochemical test that will tell you if you have or if you don't have this condition. So this talk is about telling you a little bit about epidemiology of the ME CFS, and this is just high school or maybe early undergraduate school, a slide that defines epidemiology in very simple terms as being the study of the distribution and determinants of health-related states or events or diseases in specified populations, and the application of this study to control of health problems. So in other words, epidemiology, to do an epidemiological study or to use epidemiological methods, the first requirement is the one that we need to define what the problem is that we're studying. What is the disease? What is the health status that we're talking about? And once we are able to define the problem, then we want to know how common it is, and we want to describe the problem according to place, person, and time. So that's what we call descriptive epidemiology. And then we move to analytical epidemiology, which addresses what are the determinants of risk factors for the health state or disease, and also it moves into understanding the mechanisms of disease. And finally, and there is a certain hierarchy here, then we go to interventions. What are the interventions that can prevent or cure or manage the disease, either in individuals or in whole populations? That's what epidemiology is about. And if we go to the first question of what, I hope what I told you, what I spoke about so far, already gives the magnitude of the problem we have here, because we didn't manage to define what we're talking about in a consistent way. Nevertheless, and the next slides will illustrate that there have been quite a few studies on the epidemiology of CFS or ME, and this slide illustrates the results that have been found in this meta-analysis, but also the problems behind it. So you have CFS or ME defined according to 5 different criteria, and these are the prevalence which are found. The best prevalence estimates nowadays are between 2 and 4 per thousand of the population being affected. But if you look at all the studies included here, the variation is over 100-fold. So you have over 100-fold variation in the estimates, and we can notice that not only there are variations between different definitions, because different definitions say different things and classify patients in different ways, but also within the same definition, all these cases here comply with this particular criteria, which suggests that researchers are not applying unique definitions in the same way. Of course, there are other considerations here of difference in populations and difference in other methodology used, but to a good extent, I'm sure this represents the poor standardization and how the definition is applied. When you go to the term distribution of disease, then there is some consistency there. The red line shows women and the blue line men. And we can see that the disease is more common in women in all age groups, and it's predominantly a disease of young adults or young females. And this can give some tips about the etiology. We can think about hormonal differences between genders. We can think about autoimmune diseases, which are many of which are more common in women than in men. And the other consistent finding, this has come from our study with Derek and Eliana being part of this study, which showed that the quality of life of people with ME is significantly disturbed. So the upper graphs are for men and the lower graphs are women. They are very similar in the fact that this is the normal quality of life in the normal population, and there are 8 different domains. And then you can see ME here right below. So the worst quality of life in this series here is ME, and here, note, we're comparing people with cancer, with depression, and rheumatoid arthritis, which are quite debilitating diseases. So this gives an idea of the quality of life consequences of people with ME. So I've been thinking about the difficulties of defining the condition and the implications of misclassification of diagnosis, and I'll just elaborate a little bit more on that. When you have a diagnostic test, and diagnostic test could be a blood test, could be a molecular test, biochemical test, whatever, a histology, etc., but could also be a combination of symptoms. When you have a test, and this is the gold standard, this is disease positive and disease negative, the ideal world, you want the test to detect all positives, and this is the case when the test is positive, and a negative test to detect all people who don't have the disease, of course, and this would represent the ideal scenario where a test have 100% sensitivity and a specificity. However, consider the situation where we keep the test with a very high specificity of 99%, and this situation is with a disease, this is just numbers here, or with a 10% prevalence in the population. But let's say we sacrifice sensitivity, bringing down to 80%. So what are the consequences of that? I'm not going to go into the maths in detail, because I'm sure you already did in your head, because you are many of you are much better. Most of you are much better in math than I am. But the resulting PPV, or positive prevalence. What's the bit? The 89% actually signifies signifies or means that if someone is positive by the test, it predicts the disease in 89% of the times, and the negative predicted value, VS value, sorry, it's very high, 98%, which means that if the test is negative in a particular individual, the chance that this individual will have the disease is only 2%. So that's probably pretty good. But if we do the same, sacrificing specificity, in this case specificity comes down to 8%, which is not too bad. But if you keep sensitivity at 99%, the resulting PPV, or positive predictive value, is 35%, which means that the ability of a test to predict disease in a particular individual is very low, and the negative predictive value is very high. So a negative test virtually excludes the condition. So which test would you choose here? A test with a very high specificity or a very high sensitivity? Probably I would go for this one, a test with a high specificity, even if I lose the ability to capture all my cases, even if I compromise a little bit in terms of sensitivity. That's another way to look at the data, and this comes from Recruitment, Modern Epidemiology. And this is a situation where I have an exposure, positive and negative, and disease positive and negative. And in this case, there is a true association. This is reality. So we're considering the reality here, and there is a risk ratio of 4. So in this example, the risk factor of the exposure is 4 times as likely to be present in someone with a disease compared to someone without a disease. So let's see if when we apply the diagnostic test, let's say we keep specificity 100%, but we lose sensitivity to 70%. The risk ratio continues to be 4. It's not affected at all. So our ability to look at risk factors is impaired if you lose sensitivity. And the risk difference then it goes down to 0.21 from 0.3. But if we keep sensitivity 100%, but you lose specificity, then the risk difference also comes down at the same level as in the first scenario, but the risk ratio goes down to 1.57. So you lose a lot of, in terms of the ability to detect differences, or the strength of the association is biased, in this case, towards the null value. So again, which test would you use if you're looking at risk factors? Probably a test with high specificity. So that's the bottom line. For the sake of validity, specificity of case diagnosis should usually take precedence over sensitivity for the sake of validity. And this is important if we are considering different diagnostic criteria, because we might wish to go for the more specific one, not the one who captures a large population, but those who actually capture a most restricted set of the population. And this has implications, the validity of the test also has implications when you do clinical trials. I'm not going to go into that, but just to show you, if you don't have a good sensitivity or specificity of the diagnostic criteria, the ability to detect differences, or in this case, in clinical trials, will be impaired in such a way that you can either underestimate or overestimate the effect of interventions. Right. So what's the way forward? I show you some problems. Problems with case definition, lack of biomarker, and I think in terms of future research, we should try to move from a syndrome, because we call chronic fatigue syndrome, to a situation where we find biomarker for disease, and do that. One way to go ahead is try to stratify our cases. And there are some work which has been done recently in which we can start to stratify cases according to specific characteristics. For example, one of the things we looked at is that people with ME who has a low natural killer cell function. So this, not all people with ME have, but a percentage has. Some people have very significant orthostatic intolerance, to the point that they would not be able to stand up for more than a couple of minutes. They really need to be in the horizontal position. So those with more orthostatic problems may form a different strata. And Eliana was telling about 25% of people with ME actually are housebound or bedbound, so maybe severity could be another way to stratify patients. And then perhaps using the strata, we could find some markers, and then we could devise some treatment modalities. And then at the end, maybe we will be able to define more specific entities or more specific diseases. In other words, I think the research priorities should be about case stratification, since we have such a loose definition, discovery of biomarkers, and the biobank is trying to facilitate this process, and also intervention studies. And this is a process which is it's like a circular process. And of course, as a backbone of that, we should be using appropriate epidemiological method, which talked about. I hope I convinced you that specific case definitions are ideal to use with adequate sample sizes. Longitudinal data collection, I think, is important, because just have one cross-section of individuals where the disease may not be enough, etc. And one of the reasons may not be enough is because of significant symptoms fluctuation, not only in ME, but any condition. Depending on when you present, you have a different set of symptoms. So I showed you before 3 definitions, and I show you that there are some symptoms which actually, or some signs sometimes, that are actually consistent across different definitions. And this is what this red line is about. It's about some of the commonalities between different definitions. So one way to move forward is to get, for research purposes, get people who comply with all, or at least in this case with 3 definitions. So it's about restricting the population, your sample population for studies, to include all those that comply with, let's say, 3 definitions in this case. This means adding specificity to our case definitions. And one way to do that is, of course, you combine case definitions to maximize specificity. And then you can use these people who comply with this more stringent criteria to try to explore biomarkers. And if you think you find the right biomarker, then you correlate the biomarker with clinical phenotype, and then you come back to the clinical phenotype to really find your population and try to validate the biomarker with a population with a certain phenotype. And with that, you might be able to start doing trials with people who are positive to this biomarker, so this means with one strata of the population. And also, you can try to validate the biomarker or test the biomarker in less specific cases, i.e. in those cases which are not included in initial selection of the population. And this is to deal with the lack of representativeness that you had in the beginning. But this is one way of doing, and this is the other thing that I've been thinking about during this conference, and how much modeling, mathematical modeling, actually could help in this process, not only in helping us to classify cases, not only in terms of better defined cases and subcategories of classifications of cases, but also in supporting us to tell us which are the biomarkers more promising to look after, to look for, and even which are the best targets for treatment. So, I mean, from what I've heard in the last 2 or 3 days, I think there is a good role for the mathematical modelers to help us in this process. Where am I? Oh, I came back by mistake. So I'm nearly finishing. Thank you very much for your patience. Another way to do this, to progress on research, is actually to start with clinical trials. Again, you combine case definitions to maximize specificity, or you already work with strata. And then, when you do your trials, you have, of course, those who respond to treatment and the non-respondents. In this case, you take the treatment respondents, forget about the non-respondents for the time being, just test alternative interventions in them. But the treatment respondents, we try to phenotype well who are those respondents. So you have a phenotype who will actually represent the respondents. And then you try to validate the intervention, bringing in a new population which is defined by this phenotype of respondents, and see if the intervention has worked. And then thinking about the cycle of alimentation, of feeding, or feeding of research knowledge, you can start looking at biomarkers in those people who respond to specific interventions. So there are 2 ways, possible ways to try to overcome the problem of lack of biomarkers and lack of very well acceptable, very good diagnostic criteria, because this is not the same as studying cancer. When you start with a diagnosis of cancer, and then you can move on and find out more about treatments and markers, etc. This is about a condition where we still need to develop to a point where we have a good biomarker and where we could find treatments. So that's my last slide, or penultimate actually. I'm just what I tried to speak in the last few minutes is that it's difficult to characterize the epidemiology of ME/CFS, and I suggested case definition or higher specificity and well-defined strata of people with ME/CFS should be prioritized for research at this stage. And then I also propose understanding the pathophysiology and development of biomarkers are essential for defining better the cases, stratifying them, and then finding specific treatments. And I think, and that's my question to you. Before I offer to answer any questions, of course, I'm happy to answer questions. If anyone from the field of mathematical modeling can think of ways of interacting with us, I'll be very happy to hear from you, either now or later on, because I'm sure that mathematical modeling has a very significant role to help this process of improving knowledge in this disabling and difficult condition to study. Finally, I just want to thank again for our hosts, very good hosts, and thank our personnel, our staff, are situated in the CureME team, and we have these people here. Eliana is one of them, of course, and then we work together with Immunology Department at London School, Professor Hazel Doctorow, and Ellen O'Reilly and Dr. Jackie Cliff are the main academics there who are working in this projects. And then we have from the pathogen molecular biology, or PMD, is that what it stands for, I think, department. We have Dr. Tani Clark, who does most of the genetic studies. And then we, of course, are very grateful for the funding from NIH and the charities, any charities in the UK. And of course, Eliana already showed you this map, and these are our partners in Europe that have similar interests in the area, and of course we're very happy to be here today and to have the opportunity to continue to work with people from Riga Strategy University. And of course, I would like to put more points here, so I look forward to the opportunity of working with more people who are here present. Thank you very much.